Hi, yesterday we talked about the area of polygons, in particular triangles and any type of parallelogram. Today we're going to focus on the area of a circle. The formula for the area of a circle is pi r squared, so I'm going to be working quite a bit with that. So the first example brings back the equation of a circle. So again, remember, I don't care so much about the center, even though I wrote it down. It's the opposite of what's with x and y, but more about the radius. So with this, you can either realize that this is the radius squared, and you can put that right into your formula for the area of a circle, or you could find the radius, which would be the square root of 36, 6, and then square it, whatever makes more sense in your mind. When I put 36 pi into my calculator, it was closest to 113. The next example. So this is in terms of pi. So this is asking for an exact area. It wants the area of this figure. So I first broke it into a rectangle and a semicircle. So for the rectangle, it would be 80 for the area, 8 times 10, plus it's a semicircle, so I took my circle formula, which is pi r squared, and I just cut that in half. So the radius is 4, and that comes from the fact that the diameter, the opposite side of the rectangle, would be 8. So half of 8 is 4. 4 squared is 16. 16 divided by 2 ends up getting 8 pi. Whenever in doubt of these in terms of pi parts, you could also, or in terms of pi answers, you could also figure this out in your calculator and then put in each question answer or each piece and see which decimal matches up. So example 3. So this is where it gets a little bit more complicated in terms of the composition of figures. I'm not adding figures now. I'm actually subtracting figures. I want the shaded area. So the thing with the shaded area here is, yeah, you have a semicircle here. You could figure that out. But these pieces here, these like leftover sector pieces, like cutout parts, I don't have a very straightforward way to find them. So what I would suggest is focus on what is the biggest shape. So the biggest shape would be that circle. I'm going to show you what the strategy here is. So it's as if you took this circle and you wanted to find the entire area of it. Okay, so I'm just going to keep coloring that in and talking. So I want this entire area of this circle. So that formula would be pi r squared. Then what I can do, lots of blue to kind of illustrate, is I can subtract the smaller shapes area. So the smaller, when I say the smaller shape, I say the shape I can actually find the area of. So I can find the area of that triangle. So if I subtract that out, I will be left with the shaded pieces. So originally they gave me, and I'll erase all of that. Originally they told me that B to C was 24. What else? The radius is 13, so I could use that right away in my circle formula. So it's got pi times 13 squared. But for my triangle, I had to do a little bit of side work in order to figure out its height in this case. So I took that triangle out of the figure. I know this entire length is 26, because if the radius is 13, the diameter, which is A to C, would be twice that. They gave me the 24. It's a right triangle. How do I know it's a right triangle? Well, you have an inscribed angle here. Angle B is inscribed inside a semicircle. Or you could think this inscribed angle is across from 180. So it's half of that. It'd be 90. Either way, you'd go through and then do the Pythagorean theorem. You luck out. It's a nice length. It's 10. And then I can put it into my triangle area formula. So 1/2. The base I said was 24. The height was 10. I computed both of these. And they said to the nearest whole number, put that in my calculator, I ended up getting 411 units squared. And then there's one last one I want to talk about. This one's a little bit tricky just by the look of the picture. So again, you're going after the shaded area, and they just want you to express the area. Okay? They don't want you to solve it around, and it says exact area. So when I see exact, I do not round. I don't have any decimals. I think For the most part, there's going to be a pi left in there. So we're trying to show you both of those pieces. So in this case, the bigger figure isn't always as obvious in terms of the shading, but the bigger figure would be the square. So if I found the area of the square, I could pretend all of that was shaded in. I'm not going to shade it in again. That wasn't the best way to do that. Pretend all of that is shaded in, and I try to show you this picture down here. So that's my bigger figure, and then I can subtract out actually just one circle. The reason why I'm subtracting out one circle is because there's 4 quarter circles. So altogether, it makes one circle. So my square, I said, was 6 by 6. So that was 36 for that area, minus pi times the radius squared. And they're giving you the radius right here, and you're done. So the trickiest part here is, what 2 figures are you using, or is there more than 2 figures? What's the biggest figure, even if that doesn't appear to be the shaded in part, and subtracting out the smaller figure. That's my lesson for today. I'll see you guys in class.